Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sanjadi bin Ahmadudin. Metric number AA231767. Introduction. Arithmetic progression. An arithmetic progression or arithmetic sequence is characterized by an equal difference between each of the next two terms. The fixed number representing this common difference is denoted as D. Typically, A or A1 is used to signify the first term in the progression. In the example of 1, 5, 9, 13, 17, 21, 25, 29, 30, 33, and so on. The common difference is 4, as there is an equal difference of 4 between each subsequent pair of terms. The common difference D is determined by subtracting any term from its preceding terms within the progression. For instance, in the given series, the common difference is 4, evident from calculations such as 5 minus 1 equal 5 minus 5 equal 30 plus 30 minus 9 equal 4. The arithmetic progression formula includes the common difference D and provides method for calculating various aspects such as determining the n term using the formula an equals to a plus in the bracket n minus 1 multiply d, and finding the sum of n term with the formula Sn equal to n over 2 in the bracket 2a plus in the bracket n minus 1 d, or Sn equal to n minus 2 in the bracket a plus 1, where I represents the last term in the arithmetic progression. Geometric progression. A geometric progression or geometric sequence is defined by a constant ratio between successive terms represented as A or AR power 2, with A as the first term. Geometric progression can be finite with a specific number of terms or infinite extending endlessly. For instance, 1 over 2, 1 over 4, 1 over 8, 1 over 16 exemplifies a finite geometric progression, while 3 minus 6 plus 12 minus 24 is an infinite geometric progression. The formulas associated with geometric progression include expression for the n term in the bracket an, the sum of the first n term Sn, and the sum of infinite term as infinity. The n term can be found using an equal to ar power of bracket n minus 1, or an equal to r, which is an minus 1. The sum of the first n term Sn is given by a in the bracket r power of n minus 1 over in the bracket r minus 1, where r is not equal to 1, and Sn equal to na, where r equals 1. The sum of infinite term S infinity is calculated as a over 1 minus r, when the absolute value of r is less than 1 but it's undefined, where modulus r is greater than or equal to 1. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afi bin Mispan. My metric number is AA231944. And in my part, I will explaining the video given in the question. So in the first video, we know that there are 5 bacteria that replicate every 15 minutes. After 15 minutes, the bacteria replicate to 10, and after 30 minutes, they replicate again and become 20, and so on. And we want to know at which minute the bacteria has replicate to 1280. So we will use the geometric progression formula, which is an equal to ar power of n minus 1, where the an is the n term, which is 1280, which is equal to the first term, which is 5, and the common ratio, which is 2. We got the common ratio 2 by dividing the value after 50 minutes and value before 50 minutes, which is 20 divided by 10 or 10 divided by 5. So since the n minus 1 is the power in this problem, we need to use the log method to find the n value. So we solve the problem until we get the n is equal to 9. But the 9 is not the minutes, but is the term position. So we need to times it with 15. And we got the 135, which means after 135 minutes, there is 1200 active bacteria. And then in the second video, we know that a worker receives an offer letter to work in a new company. The company offers a salary with initial value of 55,000 rupees every month, but it will increase as much as 5,000 rupees every year. And the worker wants to know in which year her salary will become 100,000 rupees a month. So in this problem, we use the arithmetic progression method, which is Tn is equal to A plus n minus 1 times D. So the information that we need to know is already given. D, which is the common difference in this video, is 5,000. The first term is 55,000, and the value at n term is 100,000. To know the n value, which is the month, we need to substitute the value given in the formula, where 100,000 is equal to 55,000 plus n minus 1 times 5,000. N minus 1 times 5,000 will get 5,000n minus 5,000. Then 55,000 minus 5,000 will get 50,000. Now we have the 100,000 equal to 50,000 plus 5,000 times n. Bring the 50,000 to left side, it will become negative. 5,000 minus 50,000 will be 50,000. After that, we will only have 50,000 equal to 5,000 times n. 50,000 divided by 5,000 will get n equals to 10 year. Next is filler table. In question 1, an oil barrel with diameter of 56 cm and full capacity experiences a small leak resulting from an accident causing the height of the oil level to decrease by 2 cm in the first moment. In the second moment, it decreases again by 1.975 and 1.95 cm in the third moment, and so on until the barrel is empty. Based on this problem, we need to find the time taken for all the oil to run out and the overall volume of oil that's spilled out. The facts that we get from this problem is an oil barrel experiencing leakage from an accident, and the second is the leakage causes the volume of the oil inside the tank drop to 0, and the third is the oil inside the barrel spill out gradually. And the ideas that come out is the barrel will run out of oil at specific time, and the problems can be solved using arithmetic progression concept. The only learning issues here is the common difference between the two terms, the overall volume of oil that spilled out, and the initial height of the oil inside the barrel. So the action plan is we need to find the common difference between two terms given, find the time taken to empty the barrel, and after the time have been found, the overall height of oil that spilled out can be found. Using the obtained height, the overall volume that spilled out also can be identified. In second question, in the end of 2021, Malaysian government released a statistic showing that Malaysia has a population around 33 million people in that year. The statistic also shows that population growth rate in Malaysia is 1.1%. Based on this information, we need to predict the population of Malaysia in the end of 2025. So the facts we get from this question is Malaysia's population at the end of 2021 is around 33 million people, and the Malaysia's population growth rate is 1.1%. And the ideas that come out is Malaysia's population increase as much as 1.1% of previous population every year. Malaysia's population in specific year also can be predicted using geometric progression concept. There is 3 learning issues from this question, which is first is the population of Malaysia in the end of 2025, the term position in this situation, and the first term in this situation. And what we need to do is identify which population in which year can be referred as first term and find the term position after finding the first term.
Hello, my name is Aiman and I'm going to explain about arithmetic progression and geometry progression for the problem background. Question 1. An oil barrel, an oil barrel experiencing a leakage from an accident caused the volume of the oil inside the tank to drop. An oil barrel with diameter of 56 centimeters, full capacity, experienced a small leak, causing the height of the oil level to decrease by 2 centimeters in the first moment, 1.975 centimeters in the second moment, and 1.95 centimeters in the third moment, and so on. The leakage of oil forms a sequence. Thus, we can tabulate the data into a table to show some information about the leakage oil. From the table, we can see that on the first second, the height of oil level decreased by 2 centimeters, and on the 2 second, the height of the level decreased by 1.975. Thus, Thus, we can derive an equation in terms of n for the number of time of oil leakage second. Thus, the oil has zero height of the oil level in a barrel. We need to find the total of time it takes to empty the oil barrel. Next, geometric progression. Question 2. In the end of 2021, Malaysian government released a statistic showing that Malaysia has a population around 33 million people in that year. The statistic also shows that the population growth rate in Malaysia is 1.1%. Lastly, we need to find the number of population of Malaysia in the year of 2025.
My name is Muhammad Azim Hakimi bin Amir. Metric number AA231181. Okay, I will explain about the solution. Question 1. First of all, find the value of D, which is the difference in the number pattern. Okay, pertama kita kena cari nilai D, perbezaan dia iaitu 1.975 tolak dengan 2 akan dapat negatif 0.025, iaitu nilai D kita. Lepas tu kita gantikan nilai itu pada rumus yang diberi iaitu AN sama dengan A1 tambah N tolak 1 D. Kita gantikan nilai A1 adalah 2. Lepas tu kita selesaikan macam biasa. Kita bahagikan dia dan nilai N yang kita akan dapat adalah 81 second. Seterusnya kita akan cari dia punya tinggi. Kita akan guna formula Sn sama dengan N bahagi 2 2A tambah N tolak 1 D. Kita gantikan nilai N sama dengan 81 tadi. A kita adalah 2 dan D kita adalah negatif 0.025. Jadi H kita akan dapat 81 cm. Seterusnya kita nak kena cari dia punya volume of cylinder. Kita akan guna rumus pi R kuasa 2 T, iaitu kita akan guna 22.7 untuk pi dan gantikan nilai macam biasa, akan dapat 1.99584 cm3. Question 2. Kita akan guna formula AN sama dengan AR kuasa N tolak 1. N sama dengan 2026 tolak 2021, kita akan dapat 5. Lepas tu kita akan gunakan formula ni, gantikan nilai ini kepada formula tersebut, iaitu 33 juta darab dengan 1 tambah 0.011 kuasa 5 tolak 1 dan 33 juta darab dengan 1.011 kuasa 4, kita akan dapat nilai dia adalah 34.476 million.
Assalamualaikum and hi, my name is Luqman Al-Hakim bin Abdul Hamid. My matrix number is AA231237. So I want to tell about discussion and conclusion. So in solving real life problem, our group applied geometry and arithmetic progression. For the better problem, we use this formula to find the time. and this formula to determine initial oil height. The D value is negative because the oil height and volume is decreasing. The cylinder volume formula help find initial oil volume. In the population problem, we use this formula to find year-end population. So subtracting 2021 from 2026 to get data for the end of 2025. This application teaches us to manage problems effectively, beneficial for students and enhancing mathematical skills. Overall, understanding geometry and arithmetic progressions prove valuable in addressing various real-world challenges. Thank you.